Action. You ready to perform, Turner? All right, so we're talking about lesson P2. P, again, is for prerequisites, this prerequisite chapter. Cartesian coordinate system and rectangular coordinate system is what we're going to talk about. What the heck is that? What is a Cartesian coordinate system? You do know already. It is a fancy term for a graph with an X and Y axis. Pretty fancy, huh? Okay, so it's called that because the first mathematician that started using the graphing system that we use, he was a French mathematician named René Descartes. And so his last name being Descartes became Cartesian coordinate system. Okay, so it's called rectangular coordinate system because of the XY axis is kind of forming a rectangle, I suppose. Okay, so super simple here. If I have a graph, which one is my x-axis? Horizontal. By default, the y-axis must be the vertical. Okay, the point where these two meet is called the what? Origin. Okay, these two axes divide the region into 4 sections, which are called what? Quadrants. Where's quadrant 1? Top right. Okay, so you can use Arabic numbers or Roman numerals. Doesn't matter, you pick. Where's quadrant 2? Top left. Doesn't that seem weird? To go counterclockwise? Okay, I think it's a little strange, but there is a reason for it, which we will discover in the next chapter. So I'll leave you hanging on that cliffhanger there. So exciting. Quadrant 2, or 2 if you're using Roman numerals. Quadrant 3 would be found down here. And of course, quadrant 4 would be bottom right. Okay, tell me about the x and y coordinates in the first quadrant. Both positive. Tell me about the xy coordinates in quadrant 2. Negative x, positive y. How about quadrant 3? Negative, negative. And 4? Positive, negative. Okay. Every time I draw this one, it makes me think of a sleeping owl. It's just where my brain goes. I don't know why. So we've got our sleepy owl in quadrant 3. Okay, tell me what absolute value means. What's absolute value mean?
How far away the number is from 0.
Okay. And how far away? I'm going to use the word distance. So distance from 0. It could also be not on a number line, but on a what I would call like a regular graph. And so it could be referring to the distance from the origin instead of just the number 0. Okay, so what symbol do we use to represent absolute value? Those 2 vertical lines. Okay, so if I'm reading this, that just means the absolute value of A. All right, if A is positive, the absolute value of A equals what? A. So, for example, the absolute value of 3 is 3. If A is 0, the absolute value of A is what? 0. Yeah, we can have an absolute value of 0. You can have a distance of 0. Okay, you can't have a negative distance there, right? Okay, this one gets tricky, and I want you to think about it. If A is negative, the absolute value of A equals what? I heard one correct answer.
Oh, my Lord.
You surprised even yourself, huh? Okay. All right. This is confusing, isn't it? Because you're like, wait a minute. You just said distance is positive, and now you're writing down the absolute value of something as negative. Okay, but here's the trick. A is a negative number. So to take the absolute value of a negative number, we have to take the opposite of A. Does that make sense? Okay. So for example, the absolute value of negative 8 is not negative 8. It's 8, which is the opposite of negative 8, or the negative of negative 8. So it's really the negative of that number that gives us the positive. Does that make sense? Okay, so you can think of that as being the opposite of negative 8 or the negation of negative 8. Okay? All right. We'll come back to this idea in just a minute. So is everybody okay with that idea? All right. Properties of absolute value. One, the absolute value of a number will always be something greater than or equal to 0. We can have an absolute value of 0, or absolute value can be positive. So whatever we end up with has to be greater than or equal to 0. The absolute value of A is the same as the absolute value of negative A. Get the same distance there. If we have two numbers that are multiplied, or two quantities, then we can split them apart and multiply their absolute values. For example, if I had 3 times 8, then that's the same as absolute value of 3 times absolute value of 8. And I'm going to put a little side note. This rule is also true for square roots. If I had the square root of 3 times 8, that is also the same as square root of 3 times square root of 8. Okay, I can do that with, those are not the same. Absolute value, square root, totally different concepts, but it's a similar property that holds true there. Okay, number 4, if I have a fraction within an absolute value, then I can just split them apart into a fraction of 2 absolute values. And I will note that this is also true with absolute value. If I had a fraction 3 over 8, that is the same as splitting it into square root of 3 over square root of 8. Okay? Works the same way there. Question on that? Okay. Turn page. All right. So we talked about multiplication and division being a fraction, but let me ask you this. Is A, let's use a real number, is 8 plus negative 12 the same as absolute value of 8 plus absolute value of negative 12? Does it work for addition? Work for multiplication? Does it work for addition? Do you get the same thing? Okay, 8 plus negative 12 is negative 4. Absolute value of negative 4 is 4. But over here, this would be 8 plus 12 would be 20. That is not the same, is it? Okay, so even though we can split that apart if it's multiplication. We cannot do so with addition. Okay, here is a huge, 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 huge mistake that a lot of people make. Very common mistake. Can this be simplified? Is that a, let's get rid of that square there, plus b? Everybody's afraid to answer. All right, let's put some numbers in there. What if I had 3 squared plus 4 squared? Is that 3 plus 4? Okay, so in other words, can I do this? Can I just split those apart? Okay, well, let's do this side without splitting them apart. 3 squared is 9, and 4 squared is 16. 9 plus 16 is 25. And that is 5. Okay, but if I split them apart, then the square root of 3 squared is 3. Why did I put 3's and 4's there? Let's just be squares. Sorry about that. And the square root of 4 squared is 4, and 3 plus 4 is 7. So clearly, they are not the same, are they? Which is correct. I mean, they can't both be right. One of them has to be the right way. So which is correct? The left. So this is the correct method to simplify that. This would be the incorrect method. So if you had something like this, it is so tempting to say that that is a plus b, but it is not. This cannot be simplified any further unless you're going to tell me what a and b equal. And if I have numbers for a and b, then I can simplify. But without knowing anything else, I cannot do anything with that. And that is a very common mistake, that we just want to make it a plus b, because it just seems right. Okay? All right, here's another one that would commonly be worked incorrectly. Guess what people will often tell me there? People say that's x plus 2. It is not equal to x plus 2. If you tell me what x is and I can sub it in, then I can simplify. But if that's all I have, it cannot be simplified. Okay? All right. Let's move on, move on. All right, example 1. Evaluate for me the absolute value of negative 4.8. I'm not trying to trick you now. It's 4.8. Okay, this one will need a little thought. Absolute value of pi minus 6. Okay, I just want you to roll it around in your brain a little bit first. Is the quantity pi minus 6 positive or negative? How do we know that?
Because pi equals about 3.
6 is bigger, right? So you're subtracting a bigger number. Therefore, this quantity is negative. Okay, just think about that for a second. Remember when I said we're going to come back to this idea in a minute? All right, just mull it over, just 30 seconds. See if you can tell me how to express this answer. And I'm going to use pi. I'm not going to turn it into a decimal. See if you can think of what we would do with this crazy thing. Anybody think they know what we would do with it? Pi plus 6. Okay, I'm going to write down all your options, and then we're going to hopefully come to the right one, but someone else tell me what you think. Okay, who else has an idea? Okay. Anything else? Anybody for negative pi minus 6? I think that's the only other combination we could come up with here. No? Okay, so let's go back to the basic idea that this is a negative number. When we take the absolute value of a negative number, we need to end up with a positive. Okay, are any of these not positive? They're all positive, aren't they? Okay, so we can't toss any out yet. 2 of them are already the same, aren't they? Which 2 are already the same? The last 2. Those are the same thing, right? You just wrote them in different orders. Okay, so let's investigate this one. Let's go back to the concept that pi is about 3. Okay, so if I had 3 minus 6, that's negative 3. And if I took the absolute value, that would be positive 3. Are any of these about positive 3? Which one are ones? The last 2. This one is about 9. Okay, so I think we need to toss that one out. These are both correct. Okay, now, why? How? Let's go back to this idea that we did not like right here. If this quantity inside the absolute value is negative, then our absolute value is the opposite of that, or the negative of that. Okay, so we knew that this was negative because 6 is bigger than pi. So if I took the negative of that, that gives me negative pi plus 6, which can also be written as 6 minus pi. Okay, so algebraically, that's how we would get to those answers. So if the quantity inside the absolute value is negative, to take the absolute value, you just have to do the negative of that, or the opposite of that. Okay? Are we all right with that? Is that sitting okay? All right, let's do a really, really simple distance problem. Okay, I'm going to draw a number line. And I'm going to just put a few integers on here. And I'm going to mark A right here and B right here. And I'm going to ask you, what is the distance between A and B? Okay. That's pretty simple, isn't it? I mean, like, if you were really at a loss, you could count. Okay, 1, 2, 3, 4, 5. Or would it be negative 5? It's 5. Distance is positive. Okay? All right, so if I wanted to support this algebraically, how would you find this algebraically? Without going, 3 minus negative 2 is 3 plus 2, which is 5. So that's our distance, right? Getting there algebraically or getting there by counting spots. So I had to take the bigger and subtract the smaller to get that positive 5. So bigger minus smaller is our distance. Okay, so if I gave you this strange little number line, and I said this is P, and this is Q. What's the distance between P and Q? If that's all I'm giving you. Q minus P. Okay, I don't know what those numbers are, but because of the way they're arranged on a number line, I know Q is bigger. They might both be negative, but I know Q is bigger. So the distance will be the bigger minus the smaller. Everybody okay with that? All right, so now let's take it to a two-dimensional graph. I want you to find the distance between A and B. But this is where my points are. I have some generic value x1, another generic value x2, some generic y coordinate there, another generic y coordinate there. And where those two come together will give me the location of A and B. Okay, what is the ordered pair at A? X1, Y1. And the ordered pair at B is X2, Y2. Okay, so what I'm asking you to find is this distance. I'll call it D for distance. I want to find the length of D. It's a little bit harder than what we just did on the simple little number line, right? I can't just count units over, and even if I could, I don't have numbers. I have some generic values here. Okay, what I'm going to suggest is that we drop this down and we bring this over so that I have a right angle there. And what I've really formed now is a right triangle. Okay, there's a theorem that we use with right triangles that you will probably all go to your grave knowing. What is that theorem? Pythagorean theorem. And what does that theorem say?
A squared plus B squared equals C squared.
Okay. A squared plus B squared is C squared. A and B are the legs, the two sides that form the right angle. C, of course, is the hypotenuse. Okay, so if I do have a right triangle, this theorem has to hold true. If this theorem holds true, then I do have a right triangle. So I'm going to apply this theorem to find this distance here. Okay, sounds good, but how long is this segment? Yeah, same as we did up here with P and Q. I'm going to take the bigger number and subtract the smaller number, and that will be the distance of that length. X2 minus X1. Okay, apply the same principle to this vertical segment. How long is it? The bigger minus the smaller. Y2 minus Y1. Now, I'm going to apply this Pythagorean theorem. Okay, so leg squared plus leg squared equals hypotenuse squared. So I have x2 minus x1 squared plus y2 minus y1 squared equals d squared. Okay, I don't want to know what d squared is. I want to know what d is. So what do I have to do? Square root. Okay, now generally, when we square root two sides of an equation, I would say don't forget your plus or minus over here. But I'm finding the length of something. Have you ever seen a ruler or a yardstick with negative numbers? I haven't either. So length of something, distance of something is positive. So I'm not going to bother with plus or minus over there on the left. I'm just going to leave it the positive. Okay, what is the square root of d squared? D. Those are inverses. They undo each other. So I get d equals, can I simplify these? Can that square and square root cancel? No. Remember what we just talked about up here where I said, no, we can't just undo both of those terms like that. So this stays. Unless I know what x1, y1, all that good stuff equals, it stays. So it's going to state all of this stuff. x2 minus x1 squared plus y2 minus y1 squared. Does that look familiar? It should. It's the distance formula. Isn't that what we were doing anyway? We were finding the distance between 2 points. This is our distance formula. So distance between two ordered pairs. Do you already know that, or should you put that on a formula sheet? That's only a question that you can answer. If you know that and you don't have any trouble remembering that, then I wouldn't bother. But if you think you might need a reminder, I'd put that on my formula sheet. Okay? Distance formula between two ordered pairs. Okay, and when you finish, don't put it back in the sheet. We'll add one more in just a minute. Okay, got it? All right, so example 2. Let's use this distance formula. Find the distance between. All right. Preston, give me an ordered pair of two integers.
3 and 7.
Okay. Sophie, give me an ordered pair of integers with at least one being negative. Okay. All right. So they have provided the ordered pairs. You're going to use your distance formula to find the distance. And talk with your neighbor or compare with your neighbor when you're done. I'm going to work it out up here as well because clearly I don't know the answer yet either since these ordered pairs just came to us. But I am going to hide my screen. I'm going to freeze it while I work mine out and then we'll compare. Okay? Talk to each other or compare when you're done. And let's see if we all get the same thing. When I set this up, y'all look up here for a second. Does this have to be x2? No. This could be x2 minus x1. If you thought it might be easier to subtract 3 minus negative 5. But then this has to be y2. Okay, so you have to start with the same ordered pair. You don't have to start with the one that's physically listed second. They gave us some good numbers. And leave your answer as a simplified radical. Something's up. Come to an agreement? Did y'all come to an agreement up here? Okay. All right, let's see what we have here. Did you get that? Okay, if you didn't, go back and figure out where things went astray and see if you have a question. Okay, personally, I think it's easier to do this without a calculator. Because we talked about yesterday, if you just type in -8 squared, it's going to give you -64. But if you're doing this by hand, you generally know, oh, I got to square negative, it should be positive. I tend to think sometimes on these that we make fewer mistakes if we do them by hand than grabbing that calculator. All right, any questions? Can square root of 89 be simplified further? How would I know? What would I do? Okay, that's one answer. I can put it in that small calculator. The graphing one won't help me. It'll just give me a decimal approximation. But I'm looking for a factor that's a perfect square. 89 is probably prime, isn't it? Can't think of anything that goes into 89. But you're looking for a factor that divides into it that is a perfect square. Just 4, 9, 16, 25, etc. divide into it. Then you can simplify it. But it doesn't. So I'd prefer just that simplified radical instead of a decimal in most cases. Okay, example 3. Use the distance formula. To determine whether triangle ABC is right. Now, not as opposed to it being wrong. What do I mean by is it right? Yeah. Does it have a right angle in it? Does it have a 90-degree angle in it? Okay, these are my points for A, B, and C. A is -3, 4. B is 1, 0. And C is 5, 4. Okay, so I can graph this, which I am going to sketch it out. However, I'm not using graph paper, and even if it looks like it might be right, I wouldn't go by that. I would still use my distance formula unless I see that I have a horizontal and a vertical segment that form the triangle. Then I know that those are right. So let's sketch this out and see what we think, and then we'll test it out with our distance formula. Alrighty, so I have -3, 4. There's A. B is 1, 0. It's down there. And C is 5, 4 up here. Okay, so I don't have a horizontal and a vertical segment, so I can't say for sure if this is a right triangle or not. If it is, which one would be the hypotenuse? Can you tell? Maybe AC, yeah, I mean, that looks like it might be the right angle. Those don't look right, do they? So if it's a right triangle, I would say this would be the 90-degree angle, making this the hypotenuse. Okay, so I'm going to label this with C for my hypotenuse. Which leg is A and B? It doesn't matter. I'll just say this is A and this is B over here. Okay, so what I'm going to do is test the Pythagorean theorem. I'm going to figure out, is A squared plus B squared equal to C squared? And if it is, it's a right triangle. If it's not a right triangle. It's just that simple. Okay, so in order to find the lengths for A, B, and C, that's where the distance formula is going to come in. Okay? All right, so that's a whole lot of work, I know. Whew, 3 distance formulas. So we're going to break it up, okay? We're going to find A, which is really segment AB. And then we're going to find B, which is really segment BC. And then we're going to find C, which is really segment AC. Okay, if your last name, listen up, if your last name starts with A through L, you find A. Last name starts A through L, you find A. If your last name is M through Z, you're going to find B. And I will do the hard one, I'll find C. And then we'll just share answers. Okay? Last name A through L, find this distance. M through Z, find this one, and I'll find C. I'm done. I have the easy one. Okay. Find your lengths, and then we'll just compare and share answers. Leave it as a radical. All right, who had my A segment? What did you get for the length of AB? Anybody?
I got 4 square root of 5.
4 square root of 5. Okay. Any others? Okay, it's not right. So I need another one. No, it's not a shocker. I mean, that came out wrong. I didn't intend to put it like, no, it's not a shocker. We're not surprised you got it wrong. I didn't mean it that way. Who got something different? I thought you were on the right track because it is 4 something. Okay, I like that one better. Did someone not simplify it? And you got square root of 32? Anybody? Okay, either one of those answers is good. Square root of 32, or since 32 has a factor of 16, it does reduce to 4 square root of 2. So either one of those is good. Okay, if you missed it, go back and see if you can find your mistake, and if you can't, let me know. All right, for my BC or segment B, people, what did you get? The same thing? So you also got square root of 32. Okay, I'll buy that. And you're welcome. I did the hard one, the horizontal, that I could just count. That length is 8. Borrow my answer. Okay, so if it's not right, it is a what kind of triangle? Yeah, it can be right and be isosceles, or it can be scalene. Not scalene. What's the word I want? Obtuse or acute and be isosceles. It's definitely isosceles. Has two congruent sides. Okay, but the question is, does the Pythagorean theorem apply here? If you had to square these lengths, which one would you rather square? Square root 32 or 4 square root of 2? Yeah, I would use this length subbing it into the Pythagorean theorem. That's much easier. I could say square root of 32 squared, that's your a squared, plus square root of 32 squared, that's your b squared, does it equal c squared, which is 8 squared. Okay, what do I get when I square the square root of 32? 32. 32 again, and 8 squared is 64. Well, look at that. 64 equals 64. So what is my answer? Yes. Happy day. Triangle ABC is a right triangle. And isosceles. Okay, question on that. All right, we have one more example. We're going to put one more formula on our sheet, and then we'll do that last example when we get back using that formula. The last formula that we're going to use today is the slope formula. That one you may have already committed to memory. Tell me if you remember the slope formula. That is the point slope form of a line, and that uses slope. Okay, but we use m for slope. It's based on a Latin word, is the reason we use m. But m represents slope. What is that formula for slope? There we go. y2 minus y1 over x2 minus x1. So this is still a formula that you have to have two order pairs for. So this is slope between 2 points. If you don't have that one committed to memory, I would add that to your formula sheet today. And that's the last one, so you can put it back in that sleeve when you're done. Okay, so that's all we'll do before lunch. When we get back, we have one more example where we're going to use the slope formula. Okay? So once you get that written down, we can, we still have a few minutes, then we'll head out to lunch. Go. Okay, so one last example here. All right, so we're going to use our slope formula for this last one. And we're going to use slopes to determine whether triangle ABC is right. Okay, and A, B, and C are exactly what they were before. Okay, so spoiler alert, the answer is going to be yes, because we already did this. But we proved that it was a right triangle using distances, which led to using the Pythagorean theorem. Okay, so now we're going to do the same problem but using slopes. How will we prove that a triangle is a right triangle using slopes? I'm not going to redraw it because I've got this sketch here. How would I prove that this is right using slopes? Any ideas? Okay, what makes a triangle a right triangle? Has a right angle. What forms a right angle?
90 degrees.
Okay, what makes a 90-degree angle? What? If it's wrong, it doesn't matter. Come on, what'd you say?
Oh, you're asking me?
Uh-huh.
Two acute angles?
The other two would have to be acute. I'll buy that. But what forms a right angle? Perpendicular segments or lines, right? Okay? Perpendicular. How can we use slopes to prove perpendicular? Perpendicular lines have slopes that are what? Opposite reciprocals. Okay, so quick review. If two lines or segments are parallel, then they have identical slopes, right? But if they are perpendicular, their slopes are negative reciprocals of each other. Okay, so let's go back to this drawing. If I told you, and I don't know what this slope is, but if I said this slope is 4 over 3, what would this slope have to be if they're perpendicular? Negative 3 over 4. Okay, if this slope was 5 over 2, then this would have to be negative 2 over 5. So that's how we're going to use slopes. So what we're going to do is still take all three segments, find the slopes of them, and if indeed this is a right triangle, two of those slopes will be negative reciprocals of each other. Does that make sense? Okay. All right, so let's put this in motion here. Okay, so first I want to find the slope of segment AB. Then I want to find the slope of segment BC. And then I want to find the slope of segment AC. Okay? All right. Let's do AB together, and then I'll let you finish up the other two. Okay, so here's our slope formula up at the very top here. So using segments A and B, if I do y2 minus y1 over x2 minus x1, then I would have negative 4 over, this becomes plus positive, positive 4. And that's a slope of negative 1. Okay? All right, you do BC and AC. I'm also going to do them, but I won't talk through them, so I won't interrupt you. And then we'll all come back and compare. Okay, when you get your answers, compare up here. Okay. All right, so look at this bottom one. What does the slope of 0 tell me? What kind of line? Horizontal. This floor has 0 steepness. The slope of this floor is 0. Okay, horizontal slope 0. Undefined would mean vertical. Okay, so clearly that's not going to help us. But look at these two. Are they negative reciprocals of each other? Yes. If we want to think of them as fractions, then I can say this is negative 1 over 1 and this is positive 1 over 1. Those are negative reciprocals of each other. Okay, so the fact that these are negative reciprocals tell me that these two, AB and BC, are perpendicular. You've seen that upside down T that represents perpendicular. So that tells me that these two are perpendicular because their slopes are negative reciprocals. Okay, well, if these slopes are negative reciprocals, which means that those two segments are perpendicular, if two segments are perpendicular, do I have a right angle? Yes, and if I have a right angle inside a triangle, then I have a right triangle. So my answer is, again, big surprise, yes, triangle ABC is right. Okay? All right, so there's no right answer here. Just think to yourself, we just took the same exact problem and solved it using distances and applied the Pythagorean theorem. And then we solved it using slopes to see if we had negative reciprocals, which would mean we have perpendiculars, which would mean we had a right triangle. Which one of those is easier to you? Who thinks doing distance is easier or makes more sense to you? Who thinks slopes are easier? Wow. Okay. So again, there's not a right answer there. But if you encounter a problem that says, is this triangle right? You have two options. Use your slopes or use your distances. Okay? All right, so we're done with notes. So for the remaining time, either work on that factoring practice that I gave you that is due Friday, or work on the homework for today, which is due Thursday. Okay? And we'll finish up these notes tomorrow. You should have more time to work on homework tomorrow in class, too, than you had today. Where's my cursor? Dang it. No, I do not have those answers. If you encounter things that you're really stuck on, bring those questions in.